Hello, today we're going to be talking about solids, liquids, and gases. So we're going to start off by discussing and listening to this video here.
In this video, you are going to learn what the three states of matter are, some examples of each state of matter, the characteristic properties of the three states of matter. The three states of matter are solid, liquid, and gas. Let us look at solids. An example of a solid is your computer. The properties of solids depend on how the particles in solids are packed. In a solid, the particles are closely packed in fixed positions and cannot move anywhere. So, solids are rigid, cannot be squashed and compressed, have a fixed shape and a fixed volume. They cannot flow. Now let us look at liquids. An example of a liquid is water. Just as with solids, the properties of liquids depend on how the particles in liquids are packed. In a liquid, the particles are again closely packed, but not as closely packed as in solids. So this means that particles in liquids can move around each other. So, liquids are not rigid, but because their particles are closely packed as in solids, they cannot be squashed and compressed. They do not have a fixed shape, but they do have a fixed volume. Beware with that one, as many students think because liquids do not have a fixed shape, they do not have a fixed volume either, but they are wrong. If someone orders a pint of beer, they cannot make it 2 pints by pouring it into different containers. As you know, liquids can flow. Finally, let us look at gases. An example of a gas is helium. This is the gas in party balloons because it is less dense than air and unreactive. Again, as with solids and liquids, the properties of gases depend on how the particles in gases are packed. Unlike solids and liquids, the particles in gases are not closely packed, they are far apart. As a result, gases are not rigid and can be squashed and compressed. They do not have a fixed shape nor fixed volume. They fill the whole space they are in.
All right. So now that we've discussed what solids, liquids, and gases are in the examples, we're going to go ahead and open up our assignment, solid, liquid, and gases, and we are going to ask our essential questions. What changes occur in particle motion, temperature, and state of pure substances when thermal energy is added or removed? If you were quizzed today, would you be able to answer this, yes or no? Solid, liquids, and gases. States of matter are also known as phases. They are described as a physical property. It describes a physical property. They are solid, liquids, and gases. The kinetic theory of matter is that all matter is made of tiny particles, atoms or molecules, which are in constant motion. How tightly these particles are packed or bonded determines on what state they take. What do you notice about the particles in the three states that are shown here? In your gas, your liquid, and then your solid. What's the differences between each one? Kinetic theory continued. Particles vibrate or move around more if the matter is heated. Particles vibrate or move around less if matter is cooled. So, for example, you have solid, liquid, and then a gas. And as you can see, the particles tend to separate as you go through each stage. M&Ms melt in your mouth, not in your hands. This is a very famous advertisement slogan. What scientific principle can the candy company be referring to? Try to explain why M&Ms melt in your mouth and not in your hands. Use words to use when you discuss this problem: energy, heating, cooling, phase change, and state of matter. So you're going to give me 3 to 5 sentences that describes what is happening, what happens, what's the difference between M&Ms in your hands versus in your mouth. Solid, liquids, and gases. Solids have a definite shape and a definite volume. Particles are tightly packed, vibrating about a fixed position. Liquids have a definite shape, but a definite volume, but not a definite shape. They can take the shape of their container. Particles are tightly packed, but far enough apart to slide over one another. How does a liquid differ from a solid? Put your answer there. Gases have no definite volume and no definite shape. They take the shape of their container. Particles are very far apart and move freely, except when they collide. Changes of state. Adding and removing their thermal energy causes a change in state of matter. States can change from one state to another. What is needed for matter to change states? Phase changes. Solid to liquid. We have melting. It's when heat goes into the solid as it melts. Liquid to solid, which is freezing. Heat leaves the liquid as it freezes. Liquid to gas is vaporization, including boiling and evaporation. Heat goes into liquid as it vaporizes. Gas to liquid is condensation. Heat leaves the gas as it condenses, and then solid to gas is called sublimation. It's when heat goes into solid as it sublimates. Now we're going to discuss what goes where. Complete the chart by clicking on and dragging the cards to their correct position. So we're going to talk about our phase change, which would be, for instance, we have liquid to gas, solid to liquid, or solid to gas. We're going to decide where these go. We have phase changes right here, and then you have your terms of phase change. This is where you'll look at your green ones and match them up to the right spot. And then you have your heat of movement for phase change. And that's where it's the green, the darker green color here. You're going to match them to the right spot. And then you're going to match them, the picture, to that particular phase change. Phase change diagram is a type of chart that shows conditions at which phase change occurs. The horizontal lines indicate points where there is no temperature change. Freezing and melting points are actually the same temperature. Make a list of many phase changes as you can. In other words, what substances change when from one phase into a different phase? For example, a candle melting. Contracting and expanding during phase change. Heating liquids and solids. Particles move faster. This faster motion causes the particles to move apart, resulting in expansion. Cooling liquids and solids. Particles slow down, and the attraction between the particles pull them close together, causing them to contract. What does the word contract mean? Write your answer down below. Heating gases inside of a balloon. Particles move faster, and particles hit inside the balloon more frequently with more force. Results in higher pressure inside the balloon than outside. This causes the expansion of the balloon. Cooling gases inside a balloon. Particles slow down. Particles hit inside the balloon less frequently and with less force. It results in lower pressure inside the balloon than outside, and it causes the contraction of the balloon or the deflation of a balloon. By looking at your previous phase change diagram, I want you to determine by dragging and clicking the labels to their correct position. With our last look here, we're going to review the properties of the solids, liquids, and gases. First, you're going to click and drag the property cards to their correct positions. Then rotate the wheels to match the images that their states of matter are. Click on the wheel and use the tool to move the window so it shows the correct image. Explain the changes that occur in the particle motion, temperature, and state of pure substance when thermal energy is added or removed. When thermal energy is added, what happens? When thermal energy is removed, what happens? Which part of the essential question do you think you would need more help on? Remember, the essential question is, what changes occur in particle motion, temperature, and state of pure substance when thermal energy is added or removed? That is all for today.